I think maybe because like I mentioned previously, there's one abstract method is because that we want to resolve the ambiguous, right? So I'm not sure that whether my answer is 100 percent correct, but if I was wrong, please just correct me. I think the reason is that this equals is like the method used for equals and hash code. So maybe some place it has some implementation for it, like if you just check arbitrary class like the object, you should also have equals something like this, like the native hash code, and also have a equals, and our like the comparator, if it implements the object method, let me check. If it implements, oh no, its interface it cannot implement. Yeah. Let me think. Oh, I think one reason is that when we instantiate, and no matter what object, at least for the equals, it will direct like you see here, our new supplier, like this anonymous class. I think at least it is like a subclass of the object, right? So it should at least have the equals method that inherit from the um, object class, like here. Something blocked me. Let me read. Oh, I cannot see the. Sorry, one second. Yeah. So where's the object? Here. So I think at least it should have the implementation for this things like this, like to compare the address. So I think this one won't provide any ambiguous, like it should have the default implementation, and also like for, but this method, like no one provide any implementation for it, so it should uh, still be the abstract one that when you provide an lambda expression or something like that, you have to you should just provide the implementation for this one. So so you're confused on the two abstract method is the equals with this compare or other abstract method. So do you find any other abstract method inside the interface? Yeah, but I'm not 100% sure. But I think this because I only find that there is a equals abstract method, but this equals just like every object should have a default equals or hash code method. Just if you do not provide anything, just have to like maybe let me try to. And I think it should also, the supplier does not have the equals, but the comparator, maybe let me create another comparator, like compare to equals to new, maybe just x1, x2, x1, just write some dummy logic, x1 minus x2, things like this. I should get rid of the curly bracket. Oh, maybe you should make it to be an integer type. And in the main method, we can do something, but this will make it kind of complicated. You see, we do not provide any implementation for the equals, but I think we can invoke the equals method. Yeah, it should default, it should have some default implementation. Just from the maybe from the object, indicate whether some object. Yep. So I think this although it seems to be a abstract method, but defaultly be implemented. Maybe I was wrong, but if you find any reason, just please correct me. But this comparator is indeed to be a function interface, because when you check it, it just use the annotation to tells you that it's a functional interface. So yeah. Oh yeah. I think no problem. Yeah. I think let's just resume our training session because it's already 11:16. So the next thing I want to introduce is the function. Oh no, the optional. So why we need optional? So just like the name infers. So the optional object is optional. So that means when you have an optional object, then that means so first optional object is a wrapper object, wrapper class, just like the future or other things like that. You will wrap your real object inside the optional object. So as the name infers, this optional object is optional. So that means the wrapper, the class that the nested object and wrapped in the optional object can be present or not. So it can either be a null value, that means there is no object inside the optional, or there can be an object in the optional. So why we need this? Because this by using the optional, it can provide us several advantage, but there's a lot of like top opinion in the internet that why we need the optional. But I checked some of it. It says that why we need optional is that like optional is basically more most commonly seen use case is like you have a method that takes optional like return type, or take the optional as the input type. So with the usage of the optional, you can like remove all the null in your code, like because previously without the optional, if there is a null value appeared, that means maybe this null value is by design. Like for example, you want to like you explicitly you want to use some null value, and you want your object to be null. But sometimes the null is caused by some exceptions, or caused by some errors, that you do not want this object to be null at all. You always want this object to have some real value. But without the optional, you do not know that whether this null is like occurs by design or just by some exception. But with the optional, like if you have, for example, you have a for example, you have a optional of you have an optional of integer, like optional of integer, and here maybe if this integer, this wrapped, this object being wrapped, by design it can be a null value, then that means if you use the optional class to wrap it, then when other people read your code, they will know that, oh, this object maybe this integer may be a null, or there may be some a value inside it. But if you just like off maybe 10. But if you just write something like integer int x equals to maybe 10 or something like that, then the other people, when they read your code, they do not know that whether this integer should should be null or not. Like they will be confused if this integer int x, when they get it, if they get a null value, maybe like if it is system out this int x, it get a null value or something like that. It will be confused that whether the null is occurred because of exception, or it designed that there is a null value because there should be like there is a design that if there's a possible that there's no any object inside for this one. So, but if you use the optional, it will be more clear that it will resolve all the nulls appear in your code. That if you just use the optional to wrap your object, then when other people read your code, it knows that this object is optional. Just like the like now the optional I said is means that the alternative, like this object can either be present or not because you wrap it in the optional. And then if there's some people that they got opt-ins like the is present, they can use the optional method to examine that whether there is an object inside the optional object or not. So maybe you can just wrap a null value here, and when you call the opt-int is now method, you should just oh, sorry, because if you use the off, then when you give the input, it requires that the input should not be null. But if you use off nullable, then you can provide a null value here. Those are different method of the optional. So you see here's a false, then that means inside this optional int object, there is no value present. So it will return you false. And so in this case, if you use the optional to handle all the object in your code, then that means if ever you see a null value, then that means this should be a error. This should be an exception, right? Because this is not to be expected. But if you use the optional, that means maybe you are expected a null value because you're expecting that there is nothing present in your optional object. And also, another advantage is that yeah, I think one is to like the first advantage is to indicate other people that this object being wrapped in is alternative. And the second advantage is to resolve remove all the null in your code. Like previously, if you have something like opt-int, maybe you need to, if you have an integer x, maybe equals some random value, you have to write some code like x dot x equals to not equals to null, things like that. There will be some null value inside your code. But if you use the optional, you can get rid of the null. In your code, you can resolve all the null things, and also use this is present to check whether there is an object or not. And also, the optional, when you use it, it can you can also use some, but I cannot think about come up with example for the chain operation by using the optional. If you have any idea, it's welcome that you can provide me some example in the chat window. But there is some method called optional door get or else. I remember like this optional ints. We can have get, like this get method is to get the wrapped integer out from the optional object, right? So for example, for now you wrapped a null value inside your op-int, and you can get it out using the get method. And, you see, it should returns you the no value present. So maybe let's change it to 10 or 100 when you run it again. You should return the 100. And if you just provide a null here, then you should use the I mean all else get. So, or just use the all else. So I think this method, like if it asks you to provide some default value, maybe 55. So run it. If it is a null value, it will return you 55. But if you provide some 100, it should returns you to 100. You see, this is the usage of all else. So it can save you some code when you're trying to write something. But still, like we can doing something similar to this. Maybe write some code like x equals to. So now we are not using the optional, right? So we can use the x equals to now, and if it is, we return like maybe print out 1 or print out 2. So this is oh no. I mean, if it is now, then we provide some default value, and not we just print out x. So it's similar to the else, but I think this code is hard to read, right? It's kind of not just as the up install else or else to be like that easy to read. And also the there's another method called all else get, right? So what is the difference between the all or else get with the all else, or sorry, it's kind of hard to pronounce, like all else. So the difference is that you see this all else get ask us to provide a supplier reference variable. So it takes the supplier type reference variable, right? So that means do you remember that what does the supplier functional interface do is that it takes nothing, but it will return an object. So here what we can do is we can provide a supplier, use the lambda expression to provide a integer here. So we use the lambda expression, no, not provide an integer, provide a supplier, provide a object of supplier type. So I think how to say it to be more accurate, that provide an object that is the subclass who implement this supplier interface. So you see, if we use this and still let's run it first. So you see, it should, because there is a value present here, so it should 100. And if we provide a null here, it should provide us the 99. So now we are not directly using the else to provide the default value, but we use the else get to provide a supplier here. So because it is supplier, then you can do some more complicated logic. Like you can, before you return the 99, you can doing something like you can write other logic, because it's a functional interface. That means this should be, you can customize your behavior, like maybe system out something, or just other logic doing something like this. And so when you use the all else get, it will first print out other logic. Like maybe in this case, you can say that there is no value present, so I provide a default value, doing something like this. You see, it said there is no value present, so I provide the default value. So by using the else get, you can customize your default behavior when you made a null value compared to just using the else. But if you just have some simple logic, maybe just using the else will be a better choice. So yep, but just provides you the choice. So this is optional, and basically just a wrapper class that wrap your real object inside it. Nothing complicated. So this is optional. And any questions related to the optional? So If no questions to the optional, we can move to a more interesting part, that is the stream API. So this part is kind of interesting, like more interesting compared to the, because you will use it a lot in your, either when you're doing just in your project or just doing lead code questions. Like the stream API can be very useful. If you have any questions related to the optional or the previous topic, like the function interface or lambda expression, you can just ask me. And if no questions, then we can move to the stream API. So, okay, cool. So if no question, assume that we are all comfortable with the previous three topic. So for the stream API, the definition, I think I cannot remember the definition, but maybe just use my own words to explain what is stream API. So like the stream API is to use to do the chain operation, and also like it can use to get rid of the for loop, right? So for example, if previously if you have a list of like a list of integer, maybe uh, when you try to filter, like I only want to get the integer that larger than 5, or I have a list of employee, I want to filter out the employee who have age less than 18, and I only want to filter out, like get who those employees who are older than 18 or something like that. Then if we do not have stream API, we can only use the for loop, right? We just for loop the whole list of the, maybe like for, maybe suppose we have an employee, or maybe here we just for loop the int x inside the list, right? And like we will create a new list, maybe list of integer. Maybe let me just write it in the code block. Cost stream. And we have a list of integer. Like this. And we want to do something like we want to filtering out those elements less or equal to 5. So previously, without the stream API, like the stream API provides you a way to replace the for loop, and also it provides you a way to achieve the chain operation. So what does it mean? So first, let me explain how to get rid of for loop. Like for example, if you previously you will use something like this. You use the for each loop to for loop your list, and you have maybe have a list of integer that's called the result, right? Result size. And here just doing something like if x is greater than 5, then you just add it into your result set. So this is what you will do, like without the stream API. But you see it's filtering out all the elements that's less or equal than 5. But with the stream API, what you can do is you can do something like this. Oh, sorry. Less equal than list.string. So this method will returns you a stream of integer. So let's just omit this arrow because I didn't complete my code. So it will returns you a stream object that contains all the integer inside the list. So when you call the list the string, then it returns you a string object, and this string object will contains all the elements in the original string. And later, what we called chain operation is that you can just use the dot and use the next method to achieve the chain operation, that is to operate further on this return object. So now remember that we already have a stream object that has all the elements inside stream object, right? And so first we can do one thing called for each. So we can okay, we can do the for each to first print out every element, maybe just system out, just for each, it needs a consumer, so consume the X and system out it. Oh, let me check. What is the arrow? Prevent. Yeah, it should. If we want to print out just for illustration, what does this stream API do is that if you use the for each, it will, like, you have an stream object contains all the elements, right? And when you call the method from of the stream function, like the for each method, it will take the elements one by one from the stream object and apply this consumer method to it, this consume object to it. Like it will print out every element. So here you can see it should, let's first get rid of this. So when you run it, you see it print out the element one by one. And also similar things is that suppose you want to apply some further like chain operation based to the stream, it will also be applied to the element in the stream one by one. So for example, if we want to filter the element, just like we do previously in the for loop, it will ask you to provide a predicate type object. So what does it mean? So predicate function interface, remember that it returns a Boolean type, right? So it will take an element and return a Boolean type. So here, what we're gonna do is we will provide a predicate object here for the filter method. This filter method will take a predicate as input. So we will give the input type of predicate. We just use the lambda expression to give the object to it. So remember this object, this lambda expression actually is providing you an object, right? Just as I write down, maybe where did I write it? So provide an instance, right? This lambda expression. So actually here we are providing an object with of the type of predicate who implement the predicate interface. So here, what we're gonna do is we just because it just asks us to like take an input, and then maybe I can even get rid of the parentheses because we only have one input parameter, and then we can just provide the Boolean type by this, like only x greater than 5. Then if x is greater than 5, then this should be true, right? So our like the predicate object, when it's applied the predicate, like the method of predicate to each of the elements. So here it has a test. When it's apply the test method to each of our elements in the stream, like 1, it will apply this test method to it, like check whether 1 is greater than 5. If not, return a false. Then when it come to 6, it will return the true. So if it return the true, when the test method return the true, the element will go further to the next step. But if it returns a false, then it will just, like the name infer, it's a filter. The element will be filtered out. So you see the filter also like return a string of integer. That means it returns the like the let me think how to say that. It returns the processed stream object, which contains only the object who are only contains the integer who are larger than 5. So here we got the stream that only contains the integer with value larger than 5, then we can use the collect method of the stream API. So this method is called the terminate step. So remember, all the previous step are intermediate step. That means those steps will not get executed until you call the terminate step. So only when you call the terminate step, all the chain operation will be actually operated. And when you call the collect, this you can just use like the collectors. This is the method that's provided by the Java. So you can just directly use it. But actually, this collect method will take rather take a collectors, like they write the logic for you, or you can customize the logic. I will do it later. Like, but for now, let's just use the collectors. So it's like the collectors is just like the collections or the executors. So there are some predefined method written by others. So you can just use it. Just use the already well-defined method. So this method will collect all the integer object in your stream object and group them into a list and return it. So you see the return type is defined in your by their collectors. So the return type, when you call the toList method, it will returns you a list, and you will assign this list to this list of integer reference variable, right? And let me just run it again. You see, now we have the same functionality that filtering out all the elements less than 5. So how does GBM know which functional interface should the lambda expression applies? So you see, this filter, it asks you to provide a functional interface predicate. So when you provide this one, just provide an implementation for your predicate object, right? You have already defined it in your method signature. Like filter, it takes a predicate as input. And also, like for example, previously when I defined a comparator, where is it? You see, when I define a comparator on the left part, I define that I want a comparator type object. So when I provide the functional interface, it will know that it should provide this implementation for the comparator functional interface. And also, like those, and also you've seen this, all the input parameters and return type are accordingly to your functional interface, right? This comparator functional interface takes 2 input. So if you just give it 1 input, it will not take it. Like, where does it go? You just provide 1. It should give you error because you're trying to assign this lambda expression to the to this comparator function interface. It should apply to the method signature defined in the compare method, right? You have to take two input, and also this thing just return an int. So if you just return x1, it's also feasible because it is an int, but it's not, the logic is not right. You have to do something like this. So All right. So does it resolve your confusion? Like, how does this? Okay, yeah, cool. So further, let us deep dive into the collectors method. It's kind of important because, and also it will return a new list. So this list is the collectors will create a new list for you and return it to the and return it. So it is different list from the original list. So here, if you just print out the original list, the original list does not get infected. So you see, it just created a just create a new list, or you can, or maybe just run it first. You can see this return list is a different list from the original list. And let me further, if you are not able to remember all those like collections or things like that, because sometimes I do not even remember those things, like because they're you can it's hard to remember all the things if you like do not use them frequently. You can you can provide your customized parameters, like so you see this collect method is an overloaded method. It can either take a collector or it can ask you to provide a supplier, a buy consumer, and another buy consumer. So this first supplier is the return object. So in this case, we want to return a list, right? Remember that in the previous example, I used the supplier to supply a list, right? Here, we can use the supplier functional interface object to supply a linked list that to maintain all the results elements. And also this by consumer, it defined it defined the behavior, like how you want to aggregate, how you want to accumulate all your elements into the supplier linked list. So the linked list that's supplied by the supplier. So in the by consumer function interface, you define the behavior, like how you want to accumulate those elements. And for the the third by consumer, it is not useful in the stream API, but it's useful in the parallel stream API. So the parallel stream API is using the fork join pool. So it's using the multiple thread. It uses the multi-threading. So remember the fork join pool, just as the name inferred, it first fork the original problem into several multiple small tasks and then join them together. So this by consumer is used for the parallel stream API for the join part. So at first, it automatically implicitly fork the object fork the task for you. So you have multiple tasks, you will have multiple thread, and those thread will each thread will have a partial of the result list, right? So at the last of the for example, if the one of the thread one handles the 145 and the second thread handles the 677 and the third thread handles the 103. So after all of the three thread finish its job, it will have three linked lists. Like the linked list for the first thread will just contains nothing because all the elements inside this part is less than 5. And the second thread will have a list of 677 because all of them are larger than 5, and the third will only contains 10. And after it, like those fork tasks being resolved, you have three lists, right? And now because your result only want one final list, so I have to group, like add all the list together. So if you are using a parallel stream, you have those three worker thread. You have to accumulate, aggregate the results into a final list, like to aggregate those separate lists into one list. So here is the um, here is the second, is the third, sorry, the third parameter came into play, that it used to define the behavior that how you want to accumulate those lists from different threads. So in this case, because we are using the stream API, so it's just using single thread. So the third parameter will be useless, but the first two will still be meaningful. Like first, we want to provide a supplier object, right? So remember, supplier does not take anything, but it will return something. For here, we want to return a linked list for like containing all the return like aggregate all the results into this linked list. And then we will need a accumulate consumer, right? Buy consumer. So the buy consumer, just as the naming first, is buy. That means takes two inputs and consume it. So the first element in this buy consumer is the return type. So the return type is a linked list, right? So it also this rest represent for the supply, the linked list that supplier supplies for us. And also this X is every element inside our stream object. So here is the each of the integer. So remember that when we use the stream API, it replaces the for loop. So it will process the elements one by one. So here we will customize our behavior, like how to accumulate those elements into our linked list. So we will do something like, for here, the logic will be easy because we're already filtering out all the elements. So here we just directly call the rest.add x. So it will just let me check. Oh, let me create another name, maybe just called R to be returned. So here you see, we just add this, we just add each integer into our result linked list. And here we'll come to the very last by consumer, which aggregate the multi-threading result. So here we will have a list, the final list, maybe we just call it final list, but name doesn't matters, the final list. And this is the list for every thread. So we will doing something like fl.add all to aggregate all the results. But actually, this is when we use the multi-threading, like the stream API, not parallel stream API, the multi-threading version of stream API. But for here, even though we just leave this part, where does it direct me to? Okay, here. Let me think if I can. So if you write the stream API, maybe you will write it in this fashion, will make your code more readable. So see, here we have three parameters. One is supplier supplies the container, like the linked list, and contains our result. And here is the by consumer define the behavior that we will want to accumulate our element. Here we just add it into the linked list. And this is for the multi-threading part. So let me run it. Maybe come out this and run it again. You will see it print out the same results, just like the collectors collect do for us. But now we just customize our behavior. And I think with this collect method, because we have defined the behavior, how to accumulate it by ourselves, right? We can even get rid of the filter. So you see, if we get rid of this one, what we can do is we can further write some logic in the by consumer. So here, previously we just add everything in the stream into the list, but now we get rid of the filter. So we have to do the field step by ourselves. So how to do it is like we just use something very simple, like if x greater than 5, then we add it into the list. So we can do something like this. It will have the same functionality, like when you run it. You see, 6, 6, 7, 7, 10. And but we have already get rid of the filter. So if we remove this condition, we add all the elements into the linked list, then it will, you see, we add all the thing into the linked list. But now we can just provide it. If x greater than 5, we add it into the linked list. So this first input parameter represents the things that's provided by the supplier. So it will be the linked list, and x is the each element in the string. So 1, 4, 5, 6, and then we define, customize our behavior, like how we want to add it into the linked list. So this is the stream API and the collect method. So we can use it to for the stream API, we can use it to replace the for loop. And also we can achieve chain operation, right? Operation. So the chain operation is something like this. You are trying to filter it and collect it, or maybe you can think we can do something more complicated, like if we want to doing some other logic, like we want to use the map method. We can map the original object into, we double it like 2 multiplied by 5. So, no. So here that means we take every element and we will return the element that's multiple by 2. So now our resulting element will be 2, 8, 10, 12, 14, 14, 26. So this is the map do. It will map the original object into a new object and add the new object into the return stream. And then you can further operate on the processed stream, like the new stream that returned by the mapped method. So this, how did the stream API achieve the chain operation is that, like, for every intermediate step, like this is called the terminate step. So but the stream, map, filter are intermediate step. So those intermediate step will return a stream object. So because it returns a stream object, then you can further like call the stream method of that stream object again. So it will achieve the chain operation. Like you, for those step by step, you can just use the chain operation to chain them together to just like doing a pipeline. But if you do not have the functional, you do not have the stream API, you have to write several lines of code instead of this one line of code. So you see, this is called a chain operation. You can do all of things just in one statement. But if you without the stream API, you have to maybe you write, like you have to first write the oh, I delete something. You have to write something like maybe like, oh, the syntax really annoyed me. So you have to write something like x equals to 2 multiple by x. You have to do something like this. You have to write several statements. It's not a chain operation, but this, you do all the thing in one statement. So this is a chain operation. And there are some commonly seen stream intermediate step, like, so first how to create a stream object. There are several ways. Like one is just like if you have a list, you can just use the those collectors dot stream. It will create a stream object. Also, you can doing something like arrays dot stream. Then because this is like the collections of list or something like that. But if you are using a array, like you have an int array, when you try to create when you try to create an stream object, you have to use the arrays.stream. And also, if you are trying to convert a character string into a character stream that you want to maybe count the frequency of each character, then you can use the chars method to convert it into a stream object. And then this will returns you a int string. So if you want to convert it into a character string, then you have to do some like map or something like that to convert it into a character string. So, but if something like this is just the object string, like you call the list.string, just returns you a object string that the object type is the integer. So you see, it's generic. It's the object string. So, and also we have the intermediate step. Things like map is it takes the map takes a functional interface. So it returns one thing and returns one object and takes one object as input. So it will you have to provide a functional interface. So it will like just a map, just as the name inferred, it will map the input object, like each element in the string, like here is the integer, and map it into a new value. Maybe you can customize your behavior, multiply by 2, or doing whatever thing you want to do it, or you can just return 1 or whatever you want to map it into, just based on your requirements. You can map it into any value. Like, and also we have the intermediate step called filter, right? So filter, you have to provide a predicate, and you can take an element and then return a Boolean value, right? And if the Boolean value is true, then this element will be further passed to the downstream. But if it is false, then it will be filtered out. It will get rid of the newly create the result string. So there, if the predicate returns a false, then this element will not present in the result stream object. So this is filter, just as I implement here. If it's like the larger than 5, then we pass it to the downstream. If less or equal than 5, because it will return false, right? Because for example, 4 is less than 5, so it will return false. Then this 4 will be get rid of the string. So those are the intermediate steps for the stream API, and there are also other things like other intermediate step, but I think those two are the most commonly used. Maybe you can give me some example if you know some of the intermediate step of the stream API. Like I will use another thing I use a lot is map to int, because sometimes when I do something, I want to convert the list to array or convert like the array to the list, and I will use this map to int. Like this map to int will unwrap your integer object into a primitive type. So it can, so here, like for example, I got a list of integer, right? Sometimes I need to return an array. So how can I do that? I can call the list.string, and then I can use the map to int. But here I just provide a dummy logic like this, and I can then collect it, or just call the toArray. I think this should work. And when I can system out this. So this should, because we cannot directly print out the array, right? So it should just give us the address of the array. So you see, it gives us the address. Let me come out this things so it won't confuse you. So you see, it print out the address of the array. And for example, if we want to check, so this is how we convert a list to an array, And if we want to check element inside the array, you can further use something called dot for each. I believe I can do it. Maybe oh, this one should return us an int array, so we cannot further apply any chain operation on it. But we can use the for each, like something like this. We can use the for each, and this is a terminate step. You see, it returns void, so it's a terminate step. But you can use it to loop through every element in the stream object, like 1, 4, 5, 6. So here we have mapped to ints, and for each we can see, but it does not explain my idea. Like my idea is to want to print out every element in the string, but maybe we can do something like quite stupid, like we converted the string, right? And now we know that we have a string. No, converted to array. And now that we have an array, right? And then we can further use the stream API to convert it to a list and then print out every element inside it. But it's kind of stupid. Like I convert the list to the array and then convert the array to the list. But I just want to uh, tell you guys that this is something that we can achieve by using the stream API. Like previously, if you want to convert your list to an array, what you need to do is that you have to create an int array that of the size of the list, right? You have to do something like this, and then you have to use a for loop to let's see, what is there? Use the for loop to for loop every index in the array, and then like assign the value to the array, right? You have to do something like this. But with the what is there? So, but miss this part. So, but with the stream API, what you can do, you see, you just with the one line of code, you just achieve all the for loop and all the creation part you want to do. So here we can get the int array. You see, just by one line of code, we achieve this functionality. So it's very neat. If you when you're coding, you can try to write your code in this style. And now we will do something similar to kind of silly, that how we can convert this array into a linked list. So in sometimes the method provides you a array, provides you an array, right? But the array is not easy to manipulate on because it has a fixed size and it's kind of fixed, so it's not feasible. It's not like flexible. So sometimes you want to convert it to a linked list, and in order to further operate on it. If without the stream API, you have to use the for loop again to add all the elements into a new list. But here we can use something called, you see, arrays.stream. This is what we will do. Like we will use the arrays.stream, and we will take the array as the input, and then it will give us an int string. So you see, the return type is an int string. So the int string is a primitive type string. It's not the object stream that we previously seen here. You see, this is a stream of object, but this is a int string. So what we're gonna do is we cannot directly collect it into a list, because remember, the list cannot contain the primitive type, right? So here we have to first use the map to object to map our elements into an object, into like map the, actually we are mapping the int to integer. So, and later we can just call the collect.toList. So this will return us the linked list that we are trying to get. Like we can try to check whether it is a linked list or not. So we can new list like this. So see, in this way, we're just using one statement to convert our array into a list of integer. Then we will be more flexible to operate on this new list. But this step is required, because if you remove it, you cannot like directly, because this return us an int stream. So the collectors to list cannot directly operate on your int string. So see, string cannot be applied to string. So the reason is that, but it does not suggest that the int array, but actually this is caused by you are providing a int array. So so now it does not, you see the int stream cannot be applied to this stream collector. So you have to convert this int stream into an object stream first, just like this, what I did here. So here, although it seems like I provided X and return X again, but actually like because the return type is object, so it will automatically wrap this into an integer for us. So if I write this, it's doing something like this, but it's redundant, already automatically converted into the integer wrapper class for us. So this is the usage for string, one of the usage for the stream API. And yep, so I think, and also there's one stream API called reduce. Like those are the intermediate step, and we have the terminate step, right? Terminate step. Now we met terminate step for each. It returns a void, right? And also we have the collect. We know that we can either collect, we can either use the collectors method that's provided by the Java, and also like provide either by any like manufacturer of Java. And also we can use I think this collector should be in the util, yeah, provided by the Java util. So you can also, it is overloaded method. You can also provide your own implementation that one supplier supply the return type, and one is called the by consumer, the define the behavior that you do, how to accumulate consumer. Define the behavior, how you want to accumulate your elements into the supplied object, like the linked list or hash map or something like that. Also, we have the reduce. Reduce will, as the name infers, you have a stream object. The stream object contains a list of object, right? Contains a bunch of object, maybe 1, 10, 9, 5, 2, like things like that. The reduce will reduce them into one value. So for example, you want to compute the sum of the list, like the sum of the list. If you use the like the stream API, you can do something like this. You can reduce them, and you see the first thing it takes should be the identity. That is the thing that you want to accumulate into it. So here we just provide an integer value that's called the 0. So we will accumulate all the elements into this 0. And later, I think I still need one thing called by operation. functional interface called binary operator. That is accumulator. That is define the way how you trying to accumulate this rest represent the zero I provided here. So we were trying to accumulate all the elements into the zero. So how we're gonna do that? We go just gonna write rest plus x. So here we're gonna return. So remember, if we only write this one line of code, it will returns the result res plus x. And then, but accumulator, does accumulator return anything? Let me run it first. $43. I think it should be the result 10, 16, 23, 13, 14, 43. Yeah, this is the result of the sum of all those elements. So let me check reduce the by operator in the by function. Yep. So it should returns a value. So the return value will be the new result. So every time we added the rest plus the x and return as the new value, and then we keep adding, then we can got the final result. That is the sum of this. So this is reduce. You use it to collect to accumulate something like you can do some functionality like this. And also like the first assignment I provided to you guys, like the lead code 49, I remember is group anagrams, right? Actually, that question you can do it with Stream API just with one statement. Like the result is asking you to return a nested list, like a list of anagrams, like you group all the anagrams into a list. Actually, with Stream API, you can just use one statement to do that. But maybe we don't have time to implement for that. But if you have interest, you can ask me. I can implement that for you. But if you're not interested in that, maybe we can we just skip that. So, but I want to further provide one usage of the Stream API that is to count the frequency of the element, just as I mentioned previously that I want to do in the stream part, that we want to count the frequency. Like for example, let me just first come out all the code. Come out all the things in the main method, and then we can doing something like I have a string of AABB or UIDAB. I just randomly write some string. And here I want to count the characters, each character's frequency from the string. So what we can do is we can use the stream API. So here, remember the things I mentioned previously that called the chars. The chars, where is it? Here. It will convert the string into a int string. This int string is like the cars, each cars of the originals in the original string. So here, if we use the cars, it will create an int string that of each of it will create an int string from the original string, and this each int is the cars of like each character in the original string. So now we have the int string, so it's a private type string, right? We cannot apply further operation on it. So the first thing we're gonna do is what I want to do is I want to map the car that now it maybe the int, but the int is represent the ASCII code of the ASCII code of the character. So I want to map it into the character. character. So what we gonna do, we can do something simple like something like this, character X. So in this case, it should map our char into the character. So now we are all good. We will have a stream full of characters. So we can further use the collect. So first thing I want to do is maybe there is a collector method called grouping by. We can directly using the grouping by. Sorry, let me first check what is the problem here. Cannot convert int to character. So can I do this? Yep. And then it should automatically wrap my car to a character, but I cannot directly write it as a character, but I first convert the int to the car type, and then Java will automatically wrap it into the character object wrapper class. So here, what we're gonna do is we use the collectors.grouping by to group to count the frequency. And here we can, the grouping by will first ask us to provide I think it should be the, I forgot, because I seldom use the grouping by. I just use my customized way to do it. Then I cannot, I don't need to remember all those things. But for this one, first you have to provide a, like if you're using the grouping by, I forgot what is the reference type of it, but I remember how to use it. Like first you have to provide a method that how you want to compute the key. So because we are trying to grouping by all the elements, right? So we have to grouping by with some unique key. So here we just grouping by itself. So like for example, we want to count the frequency. So in the hash map, each character is the key of itself, right? So we have A as key, and then we have the value is the frequency of the character A. So here we provide the way how we want to compute the key. Like for example, if we want to group all the anagrams, then like still you use a hash map to group your anagrams, right? But how you gonna compute the key is like you will sort each string and form a key. So if that is the case, maybe you have to do something like, I just, for example, if this is a string, but now it is a character, I just say if you want to group the anagrams, then maybe first thing you have to convert this string to char array. You have a char array, and char array, like something like this. And then you can use the arrays or sort to sort your char array. And then further you can like provide a string key as let me think. You have to yeah, you have already sort the char array. So if it is anagram, it should returns you a unique key, right? So you can further like use the string value of or char array. So it will return convert the char array to string again, and then you just return this key. So if you write something like this, so I just want to illustrate that this part is how you want to compute the key. Like if you want to group the anagrams, then take the string, and then how to compute the key, you just use this way to compute the key. But here, the key is just itself, so just x to x. And we can do something like here we're gonna use the collectors dot count. It's counting, right? This counting. And yeah, this should be. And this will return, you see, those are the util method that Java util provide us. So we just, so the return type we cannot determine it. The return type should always, the value should, if you use the counting method, the return type should always be like first the key is the character, right? And the value is the frequency. But because we are using the counting, so it only allows us to return a long value, like the long type. Let me see, what is the arrow? Oh, here. Also, because we are using the counting, it also restrict our return type must using the interface map. So it has a lot of restriction, right? So maybe but sometimes maybe I just want count the frequency like to be uh count the frequency, and the frequency I want to be a int frequency, integer frequency. But at here, let's say if I run it, you see it should first, oh sorry, I didn't system out it. Run it. You see here this return type is kind of restrict because we are using the predefined method provided by Java util, but it count the frequency for us. So remember that the collectors is an overloaded method, right? We can also, but instead of providing a collectors, we can also provide our customized way to do this. So here you see, actually, I just want to I just want the hash map and say I'm not satisfied with the version that you provide to me. So I will do it by myself. So what I'm gonna do is I'm gonna provide a supplier that supply this return type, right? I'm gonna return a hash map of characters and also integers. So here is the this is the supplier that uh, define the return object. And also we will have a by consumer to define the way that how we're gonna accumulate each element into our hash map, right? So now we have the hash map, and this is each element. So we just define the behavior by ourselves. Let's just say that rest put like x is the key of itself, right? And we want to accumulate the frequency, just rest get or default x 0 plus 1, something like this. This is how we gonna, is there something wrong? Cannot resolve method put in lambda expression. Let me think, what is the error? Should it because that I did not write all the things like L1 or L2, and then maybe call it H1, H2, and this third parameter is for the, yeah. So because it maybe if I do not finish all the things, it just provide me some, it suggest me some random arrow. So this, I just leave this as empty because this is used for the, like I said previously, used for the parallel stream, like multi-threading. But here the stream is just a single threaded. So we can just leave it bracket. So just omit, oh sorry, just omit the third parameters. But the second parameters, you see, it defines the behavior that how we want to accumulate the element. We want to, this is the hash map. We want to count the frequency of each character, right? So we just put the character, and so if it is already present in the hash map, we just apply plus the no, no, plus the frequency by 1. Otherwise, we just create a default value. If it is not present in the hash map, we give a default value 0 and plus 1. That means it appears once. So if we run it again, you will get the same result. You see, you have the same results. So, but this time you do not have to remember like the collectors or grouping by or how to use grouping by. You just do it by yourself, your customized way. And yeah, I think we have run out of the time. So yeah, think this will be all for today's training session. And if you have any questions, just feel free to send me a message. But if you do not have a question, you can feel free to leave now. So does runtime matter in industrial code sorting and array spend more time than using bucket sort way to rank frequency? So, but I think this two-way, you mean sort, um, sorting and array spend more time than using bucket sort way to rank frequency. The runtime, but I was assume, but you are not trying to compare the running time of the for loop and the stream API, right? You're trying to say that the sort algorithm, sort and array. But I do not use any bucket sort here, but that will be the algorithm things, I think. So bucket sort is like you group all the integer into each bucket and sort it in each bucket, right? But is that related to anything here? I am not seeing any like relations. So can you like clarify more on your question? So I think the runtime should matters in the industrial code. Like for example, when you use the stream, maybe the stream API not faster than the for loop. Maybe even it will slower than the for loop because for loop will have more predefined like more well-defined support for the for loop because for loop has a longer history, and stream API maybe sometimes even slower than the for loop when like dealing with the like maybe the parameter type of something like that. But we have parallel stream. The parallel stream is like using the multi-threading to speed up the for those iterations, so it will have better performance than for loop. This way spends all n log n time. Yeah, like if you use a quick sort, just sort using the n log n time, but using bucket sort will spend O n time. I think it is a problem on lead code. Yeah, I think if you can find a better algorithm to sort your array or things like that, it's always better to use the use the use the like a like an algorithm with better runtime. Yeah, I think it should matters in your industry code because like the less runtime always I think is always the better one. Yeah. So you're not talking. You're just talking another like question related to this part, right? You're just asking about like if we can just doing some quick sort or we can doing a bucket sort. Which one should we choose in like the industry code, right? So if that is your question, I think you just choose like not a algorithm with the less runtime. But I think there might be some trade-off. Like if you are using the bucket sort, maybe you have to use extra space. Like you will treat the space complexity with your time complexity. So maybe in the industrial environment, you have to consider about the real condition, like whether you have enough space. So if you have a like a large space, so nowadays the space storage, like the disk, become cheaper and cheaper. Maybe sometimes the space complexity is not the first prior concern, right? Maybe the time complexity should be in the first priority. But if you have a limited space storage in your company, then maybe you will be more concerned on the space complexity. So yeah. Using Stream API save lines of code, but another way use more line of code, but save times. But actually, the Stream API is nothing different than a for loop. Actually, I can just say that. Like the thing you said is like using different algorithm, but use the stream API, you can choose the algorithm, right? You can either use a bucket sort, or you can just use a sort to do that. It doesn't matter, like even doesn't matter you use a for loop or use a stream API. The stream API just you can just a tool that you can use it to achieve whatever algorithm you prefer to use. But if you are asking for the performance, like comparing the stream API with the for loop, I can say that actually they have the same performance. It won't save your time, and even in some cases that the for loop implementation will be faster than your stream API implementation, but the stream API implementation will be look more neat. So I don't know whether this can resolve your confusion. I just want to say that the stream API does not restrict the algorithm that you use. It just replaces the for loop. So if you are preferring to use the for loop or I can say that you can, so it not restrict what algorithm you use. You can just use the stream API to achieve whatever algorithm you're planning to use. So, for example, if you are trying to sort, but I think if you are just trying to, suppose you have a list of, I remember I did some lead code question that implement the bucket sort. But for example, if you just want to use the sort, then I think there's even no need for using a stream API, right? You can just, for example, you have a list of integer. If you just want to sort it, I think you don't even need the stream API. You can just sort it. And so if you want to do the bucket sort, so, but bucket sort, I think the bucket sort is kind of different to the original, like the normal sort algorithm, right? Because it's not like the merge sort. Merge sort is divide and conquer, right? It has to like merge all the result into one result. But bucket sort is like you sort it and you just sort it in each bucket, and you won't merge it together, right? Just heard before that in industry code, clean code is more important than runtime. Yeah, maybe like making your code more readable. But what I'm trying to say is that this stream API does not restrict your algorithm. You can use the stream API to replace the for loop, and if your algorithm is using some for loop to achieve it, then you can replace it by the stream API to make it more readable. But the stream API should not restrict what algorithm you use. It just replaced the for loop and made your code more readable. Actually, the performance comparing to a stream API to for loop, as I said previously, like even in sometimes you're dealing with the parameter type object, the for loop will be more faster than the stream API way. But I'm not 100% sure like what is the industry standard, like whether you should uh, but actually, yeah, for the source code I read, most of the company they just use a lot stream API instead of writing the for loop. Maybe I think if I was wrong, just correct me. But I think this, if you are trying to use a for loop, in the industry code, maybe they will more prefer to use the stream API to replace the for loop. But for the algorithm things, I think it doesn't matter. Like if you want to do the bucket sort, maybe you have to first group your group your elements into a nested list, right? Something like this, list of integer. Then you have to doing something like, let's see, but I do not have a like very clear clue like what I'm going to implement to. Like suppose I have a list and I want to group it into several nested lists and then sort it in each list. Maybe something like stream and but I'm kind of confused, like how I gonna, what is the rules that I gonna follow to group them into several lists. Like for example, I provide a new linked list, and it should be, and when I trying to group all the things into the list, what, for example, maybe here let's just say that if x is oh, I think maybe we cannot use like if x is less than 5, we group it into the first part of the list, right? Get 0, and then first of all, I think here, let me write more code here. Like what I'm gonna return is that I will create a list of integer. Then we have a list of new linked list. And we're gonna add some, there's a typo. Add a linked list to it. And we're gonna add this again. So here we're gonna have two, and gonna return this list. So here we're gonna what does already define? Just one, okay. We're gonna define a nested list, right? And we want to what is that? Count infer functional interface type. Oh, maybe I should this type isn't right, I think. Oh, there's a duplicate. There's a duplicate curly bracket. So here, what I'm gonna do is I will separate the original list element in the original list into two parts. One is less than 5, I group into the first part of the list, first nested list, and the rest, like the not rest, like if it is greater than 5, I group it in the second inner list. And then I do the bucket sort in the two lists separately. So here what I gonna do is like get 0 and then add it into the first else, just rest get 1 and then add it. I think this should work. And last is the dummy logic, like the empty. This has already been defined. Oh, I hate those things. Like I have to redefine all the elements. So now we have to like the nested list that's separated from each other, and then I think what we're gonna do is we can further like call the sort on each part. But I think let me think if I can also can we quit the session? Yeah, absolutely. You feel free. You can quit the session if you have no questions. Yeah, thank you. I think in this way, in the evaluation and the future interview, do we need to know how to code with string maybe another so it's sufficient if you just explain how it works. Yeah, I think for stream API, maybe you do not have to know like doing something like complicated, but maybe you can just know the concept and maybe at least you can do something like this, like those simple things. At least knowing how to write those things, that will be sufficient, I think. And I think in the, like for the evaluation, I think it will be just lead code questions coding. No need to worry about those things. So in is you know that even though you do not familiar with the stream API, you can do it with for loop, right? There's the same. But now if I system out this right, I just got a separate list, but I didn't sort it now. But I haven't sorted now. Uh, you see just separated into two buckets. Like one bucket contains all the element less than 5, and one contains all the element greater than 5. And because I do not want to do something, I can sort it just in here, but maybe it will be kind of stupid because I will write some code like after you got it, you just collectors dot sort your res1 dot get. This is the solution that I come up for now, but I think it's kind of stupid because every time you uh, collections, this is kind of stupid because every time you add it into your nested list, you sort it once. I think this is not a good way. But let me think. This is already the collections. If I want to do something like the sort every element, I think it will be kind of complicated that I have to convert it again to the stream. Like I have to convert it again to the stream and further doing the operations on it, like uh, uh, this this format is kind of messy, but like further you create a new linked list. What you're gonna do is you know that now you have a linked list stream, right? So inside the linked list stream, you have right. This is the return linked list, and also you're gonna have all the elements. Let's just call it L to indicate that those are list. Then you're gonna do something like collections or no collections or sort or L, and then gonna rest add L. So this will also cannot resolve. Oh, still the dummy logic. Oh, this already been defined. Maybe let's do just be sure that there's no duplicate name. So this code should also have the same functionality that You see here that we create a stream API, stream object, and of the original list and collect it into two buckets. And here, because the collect method has already returned a nested linked list for us, so if we want to further operate on it in the stream stream API, I have to use the dot stream again to convert it again to a stream of list of integers. See, and then when I collect it, I can, like, each element in the stream is a list of integer. That is the each bucket. So in each bucket, I sort it, and then I add them, add it to the result linked list, and then return it. This third parameter is like is useless here because we are using the stream. And yep, I think so. You see, with the stream API, actually you can do whatever algorithm you want to implement. It's not relevant to the algorithm. Just you can do whatever thing you want. So like with the same like similar achieve implementation, like the uh lead code 49, like group all the anagrams. You can do something just like this. You can anagram. Yeah, you can do something like this. You first use the stream API to follow each of the strings in the list. And if they are anagrams, you will use the hash map, and the value is the linked list. The linked list is the group of anagrams, right? You loop through the uh, yeah, you loop through the list and find all the anagrams group into the same bucket, and then further you can convert it to string again, and then convert the hash map into a nested list that you aggregate all the uh, value entry into the result list. So you can even use one statement to resolve the lead code 49, use the stream API. But same, you can use a for loop to do the same thing. Just nothing special. But yeah, you guys can feel free to leave the meeting if you are if you want to wish to leave. And that's those things, like we have already covered all the topic we want to talk for today, like the function interface, lambda expression, and also optional stream API. And so, but if you are quite interested in how to